All right, guys, so this is like my fifth attempt at making this video, and let's hope that it works this time. Anyway, look, I'm on Desmos right here, and I just want to talk to you guys about page 142 on this work that you're going to do tomorrow. I felt a little guilty that I was not going to be with you guys, so I give you a video. Anyway, yesterday we started talking about vertical shifts. And you're going to learn about horizontal shifts and vertical compressions and stretches and reflections and all of this. But I want you to keep the goal in mind. The goal is that you want to be able to, oh my goodness, what did I do? You want to be able to understand complicated looking functions, right? Understand the components of a function. So I'm going to graph right here. I'm gonna give you the graph of -3 times x plus 1 quantity squared minus 1, or let's say plus 1, okay? And it gives you this graph right here, an upside down parabola with a vertex at -1, 1. How did it get there? Do you think that you could be able to graph this without a calculator? Hopefully you can. All right. Anyway, so I'm going to talk about each individual piece. So you're going to know what this -3 does, what this +1 does, and what this other +1 does. All right. Each is a vital component to this function. All right. And I want you guys to learn this. So back to what we were doing yesterday. Yesterday, we started with just regular x squared, and I lost my keyboard. Where did my keyboard go? Oh, come on. Hide tools. Yes. Okay. Sorry, guys. All right. There's x squared. And if I want to make this little bitty x squared go up, I could add a k. For example, x squared plus 2. If I want to make it go down, I could subtract k or add a negative number. Here's x squared minus 2. And x squared minus 5, and x squared plus 3.9, or x squared plus 4. All right. So that's what happens with a k value. Adding a k value, adding a number at the beginning or at the end of a function, adding it to the whole function, that is called a vertical shift. Okay. So now to new knowledge. What if I want to do a horizontal shift? Well, horizontal shifts occur within the argument of the function. In other words, within parentheses. All right, so this time I'm going to say x plus h squared. All right, and we're going to go ahead and forget about k for a little bit. So let's say that my h is 0. All right, if I don't have an h value that I'm adding or subtracting to my x, then this is just x squared, right? But if I say x plus 1 squared, take a look at where my parabola goes. Or if I say x plus 2 squared, or x plus 3 quantity squared. All right, is the parabola going the way that you thought it was going to go? Maybe, maybe not. I know that when I look at this video, my face doesn't go the way that I thought it would go. So anything can happen. If we have x minus 1, all right, quantity squared, this means that my parabola is going to move in the opposite direction. All right, so you see, adding or subtracting an h value within the parentheses moves you to the left or to the right. You decide which one's which. All right. Anyway, that's a horizontal shift. All right. Next, we have a reflection about the x-axis. All right, so we're going to go back to good old x squared. If I want to reflect it across the x-axis, it says right here, you just need negative f of x. In other words, the whole function needs to become negative. So let's make it negative. Boom. There it is. I have a negative x squared. Positive, negative, positive, negative. Get it? I'm having fun here. All right, so that's that. All right. Next part is a reflection about the y-axis. If I want to reflect the function about the y-axis, it says the form is f of negative x. And in other words, you are taking the function, you're not making the whole function negative, but you're making each individual input negative. There's a difference. All right. Here we go. Are you ready to see this flip across the y-axis? Boom. There it is. It didn't do anything. Why? That's right, because it's symmetrical to the y-axis already. So let's try something like this. Let's say if we had x squared plus 4x, all right, which is not symmetrical across the y-axis. All right, let me show you what I mean. So if I make my inputs negative, which is negative x, all right, and instead of 4x, we're going to say 4 times negative x. Take a look at it. We're to the other side. In case you don't remember the original one, have it again, x squared, what was it, plus 4x, right? Look at it. What a beauty. Shout out to my Star Mount people. That came out orange and blue. But the Yakanota College is where it's at. All right. So that's a reflection across the y-axis. All right. Last, we have a compression. So I'm going to keep this one short and sweet. All right. If I have f of x equals a times x squared, all right. I forgot my equal sign. All right. So we're used to seeing just regular x squared, right? 1x squared. We don't even write the 1. We call it f of x equals x squared. But what if I say f of x equals 2x squared? That's right. What's happening? 3x squared, 4x squared, et cetera, et cetera. Or if I use a fraction between 0 and 1, look what's happening. Ooh, big function, all right? All this is happening because I'm changing my a value, all right? Here's some negative ones, all right? And that takes care of compression and stretches. So hopefully this helped you understand the transformations of function. These transformations are not unique just to parabolas, just to quadratic functions. These transformations work for any function, all right? Any polynomial, okay? So the transformations are the big idea. Adding a k, adding an h, adding an a value, you know, depends on where you place it into the function. So back to where we started. If I have the graph of negative 3 times x plus 4, and it's let's make it a cubic function. And then to that, I add 2. Why is the graph located here? Actually, I'll make it a little simpler. Let's just use a parabola. It's really easy to see transformations with parabolas. All right, this parabola has a vertex at negative 4, 2. All right, it's upside down. It's green. What made it this way? Think about it. Each individual piece, the negative 3, the parentheses, the x, the plus 4, the square, the plus 2. Think about each piece. And each piece helps you understand why that parabola is right there. That's it. Thank you guys very much. And I hope that you have a great day. And I hope that you complete all the work because we have a daily quiz tomorrow. Thank you. How do I stop this?